Cool. All right, class. So we're gonna get started. Everybody should have their quiz graded. I turned in their quiz yesterday. So if you go to Blackboard, if you go to your gray, it should show your gray on Blackboard. So if you want to see what you got on the quiz, yes, go to Blackboard. For the most part, everybody did pretty good on that quiz. Like most of you were able to do the T distribution, so that was good. Yeah, any question in regard to yesterday's quiz or anything? All right, no questions. All right, so today what we're gonna do, we're gonna be working on confidence interval again. So if you're in confidence interval, where essentially we find two number that kind of sandwich in between the population parameter. In this case, is the mean. So we want two numbers that essentially sandwich the population parameter. And we're hoping that we actually capture the population parameter with those two intervals. So if you remember for yesterday we used the Z value in order to find the confidence interval. Well, for today, what we're going to be doing, we're going to be using the T distribution because for today's lecture, we don't know the population standard deviation. We actually only know the sample standard deviation. So since we don't know the population standard deviation, we're going to have to use the T distribution. So that's where we're going to start off right now. So let me go ahead and switch over to my notes. All right, so everybody should be able to see my notes. So if you look right there, it says sigma is unknown. So just kind of ignore this part right here. We're gonna go with sigma is unknown. So for this one, we're gonna be doing the T distribution because sigma is unknown. So T distribution. So if you kind of remember yesterday quiz, like the reason why you did the T distribution other than I told you to do the T distribution was if you actually read the problem, you should have read that they don't give you the standard deviation of the population. They actually give you the standard deviation of the sample. So that's why you should have done the T distribution. All right, so let's go ahead, because we kind of already went over this when we went over the T distribution with the sampling distribution. So we're just kind of going to skip through this. All right, and let's go directly to this one. So here are the new formula. If you're going to notice, pretty much most of them are the same. The only one that's actually changing is this one and this one over here. So if you look at my standard error, instead of saying sigma divided by square root of n, we're just switching that to s divided by square root of n. Because since we don't know the population standard deviation, we're going to use the second best thing. So if you don't know the population standard deviation, what you're going to do, you're going to just use the sample standard deviation. And because we're using the sample standard deviation, we're going to be using the T distribution. So we're gonna have to be able to find the T value. And I'll show you how to find that T value using class calc. All right, but once you do the T value times the standard error, if you look at it, it says you get the point of estimate, which the point of estimate is still gonna be X bar, and you add it and subtract it to the margin of error. So that's still remaining the same. All right, so that's going to be the formula that we're using for today. So if you kind of notice, like the only thing that's changing is sigma, because we changed sigma to S, and we changed Z distribution to a T distribution because we don't have sigma. Any question in regard to the formula? All right, so let's go ahead and do this problem. So for this one, said a random sample 25 US cell phone user age 18 and older in May of 2011 found that the average number of text messages sent or received per day is 41.5 messages, with a standard deviation of 17. Assume the data of the number of text messages a day is approximately normally distributed. So that's all the information they give us. So pretty much we're just trying to figure out what is the average amount of text message that somebody either sent or received. So for part A, it says state the population and parameter of interest using information from the sample to get the best point estimate of the population parameter. All right, so let's look at this. Let's focus on this one right now. So for this one, who is the population? Like, who are they focusing on? Like, this is something we learned back probably like in week 1. So let's see if you still remember. So who's the population that we're focusing on?
The 25 cell phone users.
So you're telling me in all the world there's only 25 cell phone users? So for this one, pretty much for our population will be US cell phone users. So you were close, but you just had to take away the 25. Because remember, the 25 are just our sample, but the population is everybody who's involved in that group. So for this one, since the entire population, pretty much we're focusing on just US cell phone user, so that's everybody that we could sample from. So the 25 is just our sample. All right, so that's our population. Our population is the 25 cell phone user. Well, sorry, the US cell phone user. Who's our parameter? So the parameter is just what information are they extracting from the cell phone user? So what are they asking the cell phone user? Well, if you read, it says text message sent or received per day. So we'll say, oh, the average number of text sent or all right, so that's our population and that's our parameter. So the parameter is the average number of text messages sent or received per day. So lastly, if you look at it, say find the best estimate of the population parameter. So it's saying if I don't know what the population parameter is, like what the best estimate for the population parameter. So the population parameter that we're trying to find is mu. So if I don't know what mu is, the best estimate for mu, if you remember from yesterday, is x bar. So for this one, what is my x bar?
41.5.
Yeah, 41.5. Perfect. Thank you. So you get 41.5. All right, and that's it for A. So A, you get population US cell phone user. Parameter will be average number of text messages sent or received per day. And then our estimate will be X bar, which is 41.5. All right, so let's do B. So for B, it said find the standard error. So we're gonna find this standard error. So standard error is gonna be equal to S divided by square root of N. So if you look at our problem, sorry about that. All right, so if you look at our problem, they give us a standard deviation, which is right over here. But if you kind of read the problem, they got this standard deviation, but they got it from the 25 people. So since they got the standard deviation from the 25 people, that means that this standard deviation that we got, this is a sample standard deviation. So you do kind of want to be able to identify that, because just remember on the test, it's not going to be like, okay, this question is for population standard deviation is unknown. You're going to have to be able to read the problem, and you're going to have to decide if it was population standard deviation or if it's a sample standard deviation. So because the 17 come from the 25, we have sample standard deviation, which is 17, and then you have square root of n, which is 25. So if you do 17 divided by 5, because the square root of 25 is 5, you get 3.4. So that's your standard error. Any question for standard error?
Sure.
All right, cool. All right, so it says, what is the margin of error and what does it represent? So in order to find margin of error, we're gonna need, do you have a question? So we're gonna need to find T alpha divided by 2. All right, so in order to find T alpha divided by 2, what we have to find, we're essentially gonna have to find alpha divided by 2, but we're also gonna have to find degree of freedom. So in order to find this T value that we want, we're gonna have to find what is alpha divided by 2 equal to, and what is degree of freedom equal to. So let's do the easy one. Let's do degree of freedom. So degree of freedom, in case you forgot, is n minus 1. So n is 25 minus 1. So if you do 25 minus 1, you get 24. So that's your degree of freedom. So degree of freedom is equal to 24. So now what we want to do, we want to get alpha divided by 2. So in order to do alpha divided by 2, what we first have to do, we have to get the confidence level. So if you look right here, this is my confidence level. So we have a 95% confidence level. So we're going to put CL is equal to 95%, or you have 0.95. So what I'm going to do next, I'm going to go ahead and find alpha. So the formula for alpha is 1 minus confidence level. So you get 1 minus confidence level. So that means you do 1 minus 0.95. If you do 1 minus 0.95, you get 0.05. Everybody go for the 0.05. All right. So next, remember, we want to find alpha divided by 2. So we want to do alpha divided by 2, which is 0.05 divided by 2. So that will give us 0.025. So for this one over here, we got 0.025 and degrees of freedom of 24. All right, any question in regard to that so far? All right, so up next, what you have to do from this point on, you have to use class cal. So class cal is going to give you the T distribution. So remember, like for anything, you have to practice on it, because just seeing me doing this is not practicing, it's essentially just seeing somebody do it. So you do want to kind of practice on class calc, because that way, like in tests or in quizzes, you kind of already know how to use class calc or how to navigate around class calc. Because if you don't practice on it or don't use it, like you're not gonna get very proficient on how to use class calc. So always practice. Like even right now you should be following along and like doing this with me in class calc. So that way you could get some practice on it. All right, so here you go, class calc. So what you want to do in class calc, you want to go to stats, you want to go to distribution, and we're going to go right here where it says T distribution. All right. So where it says T distribution, you're going to see, say degree of freedom. Well, degree of freedom is 24, so we put 24. All right. But the thing is, we don't want to find the probability. We want to find what is pretty much, what is the T value. So we want to find what is the T value that correspond to the alpha divided by 2. So up next, what we have to go ahead and do is go to stats again, go to distribution. But if you remember when we were finding like the Z value, now you want to hit inverse CDF. So we want to do the inverse CDF. And right here, you put 0.025. So if you look at it, we get T alpha divided by 2. That's going to equal to negative 2.06. So all right. So if you look at it, we get negative 2.06. But for this one, what you could do, just ignore the negative and just always do the positive. So for this one, whenever you get the T value, just ignore the negative and just make it into a positive. All right. Any question on how to get the T value using class calc? All right, so up next, let's go ahead and go back to the notes. All right, so if you look right here, I wrote it down like this. And what I'm doing there, I'm just writing it like how I will write it in class calc. So that way, if I forget how to do it in class calc, I can just look at this and go like, okay, first go to the T distribution and then enter 24 for degrees of freedom. And then what you want to do, you want to do inverse CDF, and then you put alpha divided by 2. All right, so if you look right here, here's my T value. But if you look at the question, they want the margin of error. So the margin of error, I kind of ran out of space over here, so I'm going to do over here. So the margin of error is T alpha divided by 2 multiplied by standard error. So that means we get 2.06 and we multiply by standard error, which is 3.4. So I'm not going to do that in class calc. I'm going to do that in my calculator. So you go 2.06 times 3.4, and you get 7.004. All right, so that's my margin of error. So that's how much wiggle room we have. So we know that the X bar is not going to be 100% correct, but that's okay because with the margin of error, that's going to give us our wiggle room. All right. Everybody good on the 7.004? Right.
How come it's not negative?
What was that?
How come it's not negative?
Oh, can you get to kind of see, because once we do part D, you're going to kind of see why you don't put the negative.
Okay.
So let's do part D. So if part D, if you remember, it says find and interpret. So we want to do the 95% confidence interval. So for this one, what we have to do, we have to do X bar plus or minus my margin of error. So we have to do X bar, which is 41.5 plus or minus, and then we do 7.004. So like the reason why we don't put a negative over here, because if you look right here where it says positive and negative, so if I do 41.5 plus a negative 7.004, that would be 41.5 minus 7.004. But then if you do 41.5 minus a negative 7.004, you actually get 41.5 plus 7.004. So if you kind of look at it, you're at the same spot you would have been if you just didn't put the negative. So the negative really doesn't change anything because it would change it if it would just say 41.5 plus 7.004. But since it's plus or minus, you putting the negative is not really going to change anything because you're still going to get 41.5 minus 7.004 and you're going to get 41.5 plus 7.004. All right. So the 41.5 come from over here. So that's why, like for the margin of error, you never put a negative margin of error because at the end of the day, you're still going to be doing plus or minus a margin of error. All right, so let's go ahead and do this. So we'll do 41.5 minus 7.004. And then we'll do 41.5 plus 7.004. So we'll say 41.5 minus 7.004. So we get 34.496. Then what I'm going to go ahead and do, I'm going to do 41.5 plus 7.004. And you get 48.504. All right, and that's your confidence interval for this problem. Any question in regard to the confidence interval? All right, so next thing we're going to do, if you look at it, it asks for you to interpret it too. So let's interpret it. So for the interpretation, we're going to say we are 95%. The reason why we're saying 95% because of this. Confident that the population mean it's not test text set so oops, sorry about that. So that will be our interpretation. Our interpretation will be we are 95% confident that the population mean text message sent and received for a US cell phone user is between 34.496 and 48.504. And that's it for that problem. Any questions so far in regard to that problem?
No, sir.
Okay. So up next, what I want to show you, I'm going to show you how to double check your answer on ClassCalc. Okay, even though if I ask you to do it by hand, you can always double check your answer just to make sure that your answer is correct. So if you are double checking your answer on ClassCalc, what you could do, you just go to the stats button and you go over here where it says test. If you go where it says test, you go to T interval. So if you look at the t interval, it's asking for x bar, it's asking for s of x, which is the sample standard deviation, is asking for n, and confidence level. So you have to enter it in that order. So do 41.5. You go sample standard deviation, which was 17, I believe. Yeah, 17. Then you do n, which was 25. And after you do confidence level was equal to 0.95. So you do 0.95. All right, so if you look at our answer was pretty close to this because remember, we were rounding off. So our answer might have been a little bit off just because we rounded off some of the value. But if you look at it for the most case, pretty much everything is kind of spot on. It gave me the margin of error. So we got margin of error 7.004. It got a margin of error 7.01725. And just remember, because when this calculator is doing it, when it finds the t value, it's using the entire t value. So instead of us, which we only use 2.06, is using the entire number. So that's why our answer and this answer is slightly off. Yes, because of rounding off issue, but you can always look at this answer and you should be able to kind of see if your answer is pretty close. Okay, if you look at for the lower bound, we got 34.496. And if you look at this one, it's 34.482, which is pretty close to the correct answer. Well, pretty close to our answer that we did by hand. So always double check your answer. Like, this doesn't really take that long in order to check. So just check your answer just to make sure that you did it correct. All right, but that's it for that last problem. Any question for this last problem? All right, no question. So let's do the next question. So let's share. So let's do this next problem. So for this one said, for a simple random sample 24 2014 Honda Accord, 4-cylinder 2.4 liter 5-speed automatic, the mean mile per the gallon was 23 with a standard deviation of 1.5 mile per the gallon. So for part A, it said, what would be the best point of estimate for the population mean mile per the gallon for 2000? So that's a typo. It should say 2014. So it says, what would be the best point of estimate? So for this one, what would be the best point of estimate? Because we don't know what the population mean mile per the gallon for this car is, but what would be the best point of estimate for it?
23.
Yeah, 23. Thank you. So we get 23. So we get 23 because if you look right here, it says the mean mile per the gallon of these 27 2014 Honda Accord is 23 mile per the gallon. So that's why we're getting that 23. Yeah. Any question in regard to that? All right, no question. So let's do part B. So for part B, it says find the margin of error for a 95% confidence level and explain what it represents. All right, so once again, we're gonna find the margin of error. So to find the margin of error, we first have to do standard error. So to find standard error, we have to do S divided by square root of N. So let's see. So for this one, what's my S? What's my sample standard deviation?
1.5.
Yeah, 1.5. In a little bit, I'll show you like a little trick to how to know if it's from a sample or if it's from a population. All right, so let's do this. So what's my N?
27.
Yeah, 27, perfect. So let's do 1.5 divided by square root of 27. So if you look at it, you get 0.2, and what do we say, 9? All right, everybody good so far? Standard 0.29.
Yes, sir.
Alrighty then. So let's go ahead and do this. So now we're gonna go, well, let me show you the trick. All right, so kind of look at the sentence. So anytime, so if you look at a sentence, if that sentence has a sample, so if you look right here, they tell us this is a sample of 24. Or sorry, sample of 27. I'm thinking about the last degrees of freedom. So they tell us this is our sample. So anything that they give us in this sentence, that's going to be a sample mean or a sample standard deviation. So if you look at it right here, here's the mean. So this mean comes from this sample. Here's the standard deviation. So that means that standard deviation comes from the sample. Because if the standard deviation didn't come in that sample, essentially the standard deviation, they will give it to you in a different sentence. So if in the sentence they say this is a sample, and then they tell you this is the mean and this is the standard deviation, they're telling you that this mean and standard deviation is coming from that sample if it's all in the same sentence. If they're in separate sentence, most likely it's because they're a population. So if they say here's a sample 27 and we found the mean to be 23, and then in the other sentence it says the standard deviation was found to be 2.5. Most likely that 2.5, that's a population standard deviation, not a sample standard deviation. So you kind of want to look at the sentence and see what is given in that one sentence to kind of figure out if there's a sample or population. All right, well, enough about that. So let's finish off the margin of error. So for the margin of error, we have to do T alpha divided by 2 multiplied by standard error. So I already found standard error to be 0.29. So now we have to find what T is. So remember, for T, we have to find two things. We have to find alpha divided by 2, and you have to find degrees of freedom. So luckily for us, we already did the alpha divided by 2 when we did the last problem. So what was the alpha divided by 2 for the last problem?
0.025.
Yeah, perfect. 0.025. Lastly, what's my degrees of freedom?
26.
Yeah, 26. In case you're wondering, how do we get 26? Degrees of freedom is equal to n minus 1. So we do 27 minus 1, which is 26. All right, so in class calc, I'm going to give class calc this information. So if you remember how to enter this into class calc, you do T distribution, you get 26, and then you do inverse CDF, and you do 0.025. So that's how I'm going to enter it into class calc. So let's go ahead and transfer over to class calc. No, not all alpha divided by 2 is equal to 0.025 because it depends on what your confidence level is. For the last problem, I'll change the confidence level if I still chose 95, for that way you can kind of see that is not always going to be 0.025. It depends on what your confidence level is. If your confidence level is 95%, then yes, your alpha divided by 2 will always be 0.025. All right, so we do T distribution, we do 26. Then we go ahead and we do, you're welcome, inverse CDF. So you do 0.025. So if you look at that, this is our T value. So remember, for the calculator is going to use all of this. But for us, we're just going to use 2 decimal places. So we get t alpha divided by 2 is equal to 2.06. So we're only going to use 2.06, not the entirety. All right. Everybody good on how to find the t value using class count? All right, so let me go over to my notes so that way we can continue on with this problem. All right, so we found t to be 2.06. We found standard error to be 0.29. So I'm going to go ahead and do this in my calculator. So 2.06 multiplied by 0.29. So you get 0.5974. But they just round this up to 0.6. So if you go to 9, the 9 round up to 5 to 6. All right, so we get 0.6 for my margin of error. So remember, the margin of error, you're telling me that's my wiggle room, because you're saying like, I know we're not going to be 100% correct with the point of estimate, but the margin of error, you're telling us how off our point of estimate could be. So it's saying it could be within 0.6 of X bar. All right. Everybody good for B? All right, so let's do C. So if you look at C, it said construct a 95% confidence interval for the mean gas mileage of 2005, well, typo, so let's say 2014 Honda Accord and Interpreter. All right, so let's do the 95% confidence interval. So we have the point estimate of 23, which we found in part A. And then we have the margin of error of 0.6 that we found in part B. So all we have to do is do 23 plus or minus 0.6. If you do that math, you get 24.4 and you get 20, oops, I did my math wrong. 22.4 and 23.6. So that's my confidence interval for this one. And we're all done with the confidence interval. Any question in regard to the confidence interval? All right, so now what we want to do, we want to do the interpretation. So let's do the interpretation. So let's say we are 95% confident that the mean mile per the gallon for a 2014 Honda Accord is between 22.4 and 23.6. Okay, so I'll give you a minute to write that down. So if you look at it, say we are 95% confident that the mean mile per the gallon for a 2014 Honda Accord is between 22.4 and and 23.6. And that's your final answer for C. Any question in regard to C? All right, so let's go ahead and do this. So for D, it said, based on the confidence interval found in part C, is it likely that the mean mile per the gallon of a 2014 Honda Accord is 15? So it's asking us, hey, like using your confidence interval, is it likely that the mean mile per the gallon is 15? So what do you think? Because if you look at our confidence interval, the confidence interval telling us it should be between 22.4 and 23.6. So is it asking, is it likely that 15 is the true mean for the mile per gallon for a 2014 Honda Accord? So what do you think? And crickets. All right, so let's do it. So if you look at it, essentially what you're trying to find, you have your interval, and you're trying to see does 15 fall in between these two numbers, or does essentially is it below it, or is it above it?
Below it.
Yeah, so it's below it. So it's below it. So it doesn't fall within this interval. So we're 95% confident in this interval. So for this one, we're gonna say like, no, it's not likely. So we're gonna say no, it's not likely because we're going like, since it doesn't fall within this interval, it's most likely not, pretty much not gonna happen, because if it would have happened, that 15 would have fallen between those two numbers. But since it doesn't, we're kind of more suspicious, saying like, okay, maybe it's not true. All right, but that's it for that one. Any question in regard to the last one? All righty then. So. All right, so for this one, let's change this percentage just to get some variation. Let's do 90%. So we're gonna do a 90% confidence interval for this one. So we'll say owner of Starbucks randomly selects 16 coffee shop and measures the temperature of the coffee sold at each of the store. He knows that the sample mean temperature should be 162 degrees Fahrenheit with a sample standard deviation of 10 Fahrenheit. Find the 90% confidence interval of the mean temperature to guarantee a Starbucks customer the temperature of coffee sold to them. Assume the data of the number. Let's pretend we never saw that. All right, so let's do this. So first thing we're gonna do, we're gonna go ahead and just label everything. So what is the 16? What does the 16 represent?
N.
N, perfect. All right, let's continue with the easy. What does the 90% correspond to?
Confidence interval.
Yeah, so CO. Next thing, what does this 162 represent?
That's our mean.
Yeah, so the mean. So what type of mean? That's the sample mean or that's the population mean?
It's a sample mean.
Perfect. We're on it. What about this 10? What does this 10 represent?
Sample standard deviation.
Yeah, good. Perfect. All right. So we have n is equal to 16. We have confidence level equal to 90%. We have x bar is equal to 162. And we have s, which is equal to 10. So we have all the information for us in order to do this problem now. So first thing I'm going to go ahead and do, I'm going to go ahead and find standard error. So let's do that in pink. So standard error is s divided by square root of n. S is 10 divided by square root of 16. So if you do square root of 16, square root of 16 is 4. If you do 10 divided by 4, you get 2.5. Any question on where did this 2.5 come from?
Oh, sir.
All right, perfect. So up next, we're gonna go ahead and do, we're gonna go ahead and just find my margin of error. So before I find my margin of error, we have to find alpha divided by 2, but we also have to find degrees of freedom. So let's do the easy one first. Let's do degrees of freedom first. So degrees of freedom, what would degrees of freedom equal to?
Equal to 15.
Yeah, perfect, 15. Remember, if you do 16 minus 1, you get 15. Perfect. All right, so now let's do alpha divided by 2. So for alpha divided by 2, remember, to get alpha, you do 1 minus confidence level, which is 1 minus 0.90. And the 0.90 is coming from this 90%. So if I do 1 minus 0.90, you get 0.10. So now if I do alpha divided by 2, you get 0.10 divided by 2, which is 0.05. So if you look at it, the alpha divided by 2 will change, but kind of know like if it's 95%, it will always be 0.025. If it's 90%, it will always be 0.05. So it does change with the confidence level, but once you already know what it is, like it's gonna always be that value. But any question on how I got alpha divided by 2?
No, it's good.
All right, so now you have to go over to class calc and you have to do these calculations. So for class calc, what you want to do, you're going to do t distribution, and then you're going to say, hey, we have a degree of freedom of 15, and then you have to do inverse CDF. And then you put 0.05. So right here, you put degrees of freedom. Right here, you put alpha divided by 2. Like you should be writing this down when you're doing these type of problem. Like you want something to kind of remind you how you got it in class calc. Because if you put the answer that you got in class calc and you don't put how you got it or what you pushed into class calc, you are gonna forget how to do this in a test or in a quiz. You're not gonna get this right. So do write it down for that way you know like how to do it in class calc. So let me go transition over to class calc. Let's transition over to class calc. All right, so everybody should be seeing class calc right now. So we go to stats, we go to distribution, and we go to the t distribution, and we say, hey, we have a degree of freedom of 15, and that's it. And then we go to stats, we go to distribution, and we do inverse CDF. So inverse CDF, you do 0.05. All right, and if you look at it, we get negative 1.75, but like I said before, always make it into a positive. So we get t is equal to 1.75. All right, everybody good with the 1.75? All right, everybody is good. So let me go ahead and transition over. All right. So if you look at it, I got my t value to be 1.75. I got standard error to be 2.5. So if I want to get margin of error, you go t alpha divided by 2 multiplied by standard error, which is 1.75 multiplied by 2.5. So if I get 1.75 multiplied by 2.5, you get 4.375. But if you look at the 7, I'm going to round up this 3. And where are you going to make this into 4.4? Everybody good on the 4.4? All right, everybody's good. The last thing we're going to do, we're going to get our sample mean, which is 162. And we're going to add it and subtract it to 4.4. So if we do 162 minus 4.4, so the 162 minus 4.4, 162 plus 4.4. So you get 157.6. And then we'll do this again, but we do positive or we do addition and we get 166.4. And that's your confidence interval. And we're all done with this problem and we're all done with this lecture. But any question in regard to how I got this confidence interval? All right. So you have to make sure that I'm on the right track or my answer is somewhat correct. What I'm going to go ahead and do, I'm going to go to class calc and I'm going to double check this answer. So in class calc, what we want to do, we want to go to stats, we want to go to tests, and we want to go right here where it says T interval. So right here you say X bar was 162. If you look at it, want S was, what was S? S was 10. So you put 10 for S. Then it want N is 16, if I remember correctly. And lastly, confidence level was 0.90. All right. So if you look at what class calc is giving us, class calc is giving us 157.617374. If you compare that to what we got 157.6. So you know you're on the right track because the answer are pretty similar. If you look at this one, we got 166.38. If you get the 8 and round up this 3 to a 4, that's exactly what we got using pretty much by doing it by hand. So if you look at it, this is validating our answer that our answer is correct. So you should always do this. Like if you're doing it by hand, double check your answer by just using class calc. All right, but that's it. Any question in regard to this last problem?
No.
All right. So let's stop this share. Wait. All right, so you're all, well, we're all done with today's lecture. So I'm gonna show you where to go for the homework. Let me make sure I'm on grade. All right, so let's see. All right. So for today's lecture homework, all you have to do, you go to Math 132, Summer 2020. You want to go where it says confidence interval. So chapter 8, confidence interval. You click right here. All right, so this was yesterday homework, confidence interval sigma unknown. So that's yesterday homework. And remember, this is what you're going to get quizzed on today. You're going to get quizzed on confidence interval sigma known. So you should already know, hey, sigma should be known for today's quiz. So if you do confidence interval when sigma is unknown for today's quiz, you are going to get the question wrong. You want to do what we did yesterday. So for yesterday, we did the Z interval. So if you click right here where it says confidence interval sigma unknown, that's where you're going to find your homework. So that's where you find your homework. And for today's quiz, let's see, which number is today's quiz? I think 17. But let me make sure.
Yes, it is 17.
17? Cool, thank you. Yeah, so for today's quiz is quiz number 17. So if you go all the way down here, click right here, and you go to quiz 17. So if you look at it, there's only 2 more quizzes left after today. So we're almost done with this. So quiz 17 will be for today. All right. So also today we're gonna be working on the activity. So let me see which activity is it for today. Past activity.
I think it's activity 18.
18? That's the wrong one. Yeah, so you want to do activity 18 today.
We're doing 19 today, actually.
Yeah, it should be 19. Cool. All right, so you're gonna work on activity 19 for today. So that's what I'm gonna break you up into your room for today. So let's do a breakout room. Let's stop the share. Let's stop recording.